sutera nak raja muda. Allah tolonglah
Hello everyone, today I want to talk about differentiation. What is the differentiation? The differentiation is the method of finding the derivative or rate of change in a function. The rate of change in a function is defined as dy dx function to y. We use derivative to determine the maximum and minimum values of particular function.
Now we move to another slide, which is the subtopic. This topic has the four subtopic, which is the first, related rate; second, analysis of function 1 and 2; third, apply maximum and minimum problem; and lastly, Ross theorem and mean value.
What is apply maximum and minimum problems? Apply maximum and minimum problem involves finding a highest and lowest value of quantity in real life scenario. The process called optimization that uses differentiation to determine the optimal solution. This is what we use apply maximum and minimum problems in our real life by maximizing profit, minimizing risk, and minimizing cost.
And now we add how to solve. First of all, draw a diagram if doesn't have one and label the diagram with the information. Secondly, identify the quantity to be maximum or minimum. Thirdly, find a formula for the quantity to be maximum or minimum. 4. Find and let the derivative equation to the zero and find the value of the variation. And 5. Do a second derivative. If second derivative more than 0, it means minimum value. But if second derivative less than 0, it means maximum value. And lastly, find value, we substitute another value in the equation. Now, you're done.
And now we all in the problem statement. A closed rectangular box with square base is to hold 216 cm3 of water. The material for the sides and for the top or base costs RM1.50 per square centimeter and RM2.50 per square centimeter respectively. Let's X denotes the size of the base and Y the height of the box as shown next. Firstly, we go to the question A, shown that the cost C of the material is C equals to 5x squared plus 1296 over S. To solve this problem, we must know a clue from the problem statement. We have 4 sides, 1 top and 1 base. We can get the error value of side with multiply S by Y, and the error value of top and base, we multiply the S by S because they have the same value. Next, the problem statement shows us that the value of volume is 216 cm3. The price of side is RM1.50 and top or base RM2.50. As we know, the formula of volume is X squared multiplied by Y. So, we can get the value of Y. We move X squared to the left side and then we can get the Y. And then, to get the value of cost, we must add all the price given of box, which is 2.5x squared plus 2.5x squared plus 1.5xy plus 1.5xy and plus 1.5xy plus 1.5xy, and then we get the value of C 5x squared plus 6xy. So after that, we put the value of 5 into the Y, which is 5x squared plus 6x multiplied by 216 over x squared. And then we simplify the s and then we can get the answer.
And now we move to another question, which is the question B. The question B asks we to find a value of S and Y that we minimize the cost of the material. So the step 1 you need to do is find derivative. So, jadi persamaan yang kita dapat dekat question A, iaitu C bersama dengan 5x kuasa 2 tambah 1296 over X. Jadi persamaan ni kita macam nak modify sikit, kita tak nak depan. So, X tu kita bawa ke atas. Jadi kuasa positif tu jadi kuasa negatif. Jadinya 5x kuasa 2 tambah 1296 jadi X negatif 1. Sebab apa? 1 bawa atas jadi negatif 1. So, lepas kita dah buat tu, kita boleh start dah derivatifnya. Apa syarat derivatif? Syarat derivatif, kuasa bawa depan darabkan dengan nombor depan and kuasa tolak 1. Okey, jadinya 5x kuasa 2. 5 darabkan dengan power of 2 dapat 10x dan tolak 1 kuasa tu dan dapat x. And 1296 tu darabkan dengan power of negative 2 dapat negative 1296 dan kuasa tolak 1 dapat x, negatif 2. So jawapan dia, kita kena positifkan balik. Tadi kan kita dah negatifkan kuasa tu sebab nak senang kira-kira. So kita kena positifkan balik. So dapat 10F negatif 1296 over X kuasa 2. Sebab X kuasa 2 tu kita kena bawa ke bawah untuk positifkan dia. And now we add the step 2, which is let the derivative equal to 0. Persamaan tadi tu kita kena samakan dengan kosong, which is kosong sama dengan 10x tolak 1296 over x kuasa 2. Jadi kita kena bawakan negatif 1296 over x kuasa 2 tu untuk kita positifkan dia. So kita dapat 10x over 1296 over x kuasa 2. Okey, sekarang ni kan kita ada over x kuasa 2 tu kan. Over x kuasa 2 tu kita kena darabkan dengan 10x. Okey, kita ada 10x darab dengan x kuasa 2. X dengan x kan baru bersama. Bila baru bersama, kuasa dia kena tambah. Jadi 1 tambah 2 dapat berapa? Dapat 3. Jadi 10x kuasa 3 bersamaan dengan 1296. Okey kan, kita dah dapat tu. Kita kena 1296 tu kita kena bahagikan dengan 10. Jadi kita dapat 648 over 5. Okey, kita nak bagi x tu lonely. Kita nak ada x tu kawan. Sekarang partner x tu adalah kuasa 3. So kuasa 3 kena bawa ke sebelah kanan kita. Bawa ke sebelah kanan tu kita kena punca kuasa 3. Jadi x kita dapat nilai x equal to 5.061. And jangan lupa unit CX. And now we add the step 3, which is second derivative test. Okay, tadi kan kita dapat first derivative, which is 10x minus 1296 x kuasa negatif 2. Itu kan first derivative kita. So kita kena derivatifkan lagi sekali. Untuk apa? Untuk kita tahu nilai x yang kita dapat sebentar tadi tu nilai minimum ke maksimum. So kita kena buat lagi sekali derivatif, which is 10x. Kan saya kata kuasa bawa depan, kuasa tolak 1. Jadi 1 darabkan dengan 10 dapat berapa? 10. Jadi 1 tolak 1 dapat berapa? Kosong. Jadi x dah tak ada. So jadi 10. And 1296. Negatif 1296 x kuasa negatif 2. Negatif 2 darabkan dengan negatif 1296 dapat 2592 dan kuasa tu kena tolak 1. Jadi x negatif 2 tolak 1 dapat x negatif 3. So x negatif 3 tu kita kena bawa kat bawah. Sebab apa? Kita nak kuasa tu positif. Jadi 10x tambahkan dengan 2592 over x kuasa 3. So kita nak tahu, kita dah dapat second derivative kan. So kita kena masukkan nilai x tu dekat x punya variable. Bila kita dah masukkan substitute nilai tu, kita akan dapat 29.995 lebih besar daripada kosong. Ingat tak tadi saya kata how to solve? Kalau how to solve, kalau lebih besar daripada kosong, which is the meaning is the value kita dapat tu adalah minimum value. Now we move to the last step, which is the step 4. We need to find the value of y. Okay, tadi kan Dini dia ada buat satu equation, which is the value equation. Kan value equation tu kita perlu substitutekan nilai x ke dalam value equation tu. So y equals to 2.16 dalam kurungan 5.061 punca kuasa 2. So kita akan dapat nilai y dia 8.433 cm. Ingat, kita punya measurement jangan lupa.
C, we need to find the minimum cost of the box. To find the minimum cost of the box, we need to use equation C, which is 5x squared plus 1296 over x. Then the x need to replace with 5.061. Okay, the equation will be C minimum equal to 5 in bracket 5.061 square plus 1296 over 5.061. Then the C minimum will be RM 384 ringgit and 40 cents. After studying this topic, we had learned and understood the idea of differentiation. Application of differentiation can be used to determine the maximum and minimum value to solve problem. Therefore, we need to apply the formula by analyze and find the first and second derivative to find the highest and the lowest of the problem. The application can also apply in our daily life because it can solve the problem that relate to the value of volumes, such as trying to minimizing the cost and finding the less amount of material to make a particular object.